welcome to the Deep Dive. Today, we're going to be diving deep into Amdahl's law.
Ooh, exciting.
It's a concept that, it comes from computer science, but it really has applications kind of everywhere, beyond just the world of computers and ones and zeros.
Yeah, I think you'd be surprised.
And we've got a great document here that really goes deep on Amdahl's law.
It really breaks it down.
And by the end of this deep dive, you're really going to not only know what Amdahl's law is, but why it matters.
And why is so important.
So
what's really fascinating about Amdahl's law is that it gives us this framework for understanding the limits of improvement. Like, how much faster can we really make something if we can only improve part of it? That's the question it helps answer.
Okay, so that's a really interesting question.
Right.
Can you give us an example? What do you mean by that?
Absolutely.
Okay.
So imagine you have a task that has two parts, right? And let's say one part can be sped up, you can make it faster, but the other part can't be improved at all. No matter how much you try and optimize that first part, you're always going to be limited by that second part, like a bottleneck.
It's like a narrow section on a highway, right?
Yes.
Even if you widen every other lane,
Exactly.
that one spot's going to back everything up.
Yeah, that's a great analogy, yeah.
Yeah.
So Amdahl's law, it actually gives us a way to quantify that relationship.
Okay.
So there's a formula for it, but don't worry, we're not going to get into, complex math or anything like that.
Right.
The key is really understanding the concept.
Okay, so let's say we've got a task that takes 100 minutes, right?
Yeah.
And our source actually uses this example.
Yeah, they do.
And so of those 100 minutes, 60 minutes can be sped up somehow, right?
Okay.
You get a faster computer or something, but the other 40 minutes, that's just inherent to the task. There's just
Right.
no way to make it faster.
It's sequential.
Yeah,
It
exactly.
has to be done in a specific order.
And so even if we could, snap our fingers and make those 60 minutes happen instantly,
Yeah.
we'd still have those other 40 minutes, right?
Yeah, that's exactly it.
So, we're constrained.
That's your bottleneck.
Yeah.
You're limited by that unimprovable part.
Wow. So even with infinite resources thrown at that first part,
Right.
we're still stuck with those 40 minutes.
Right. And in this specific example, the best possible speed up you could get is 2.5 times.
Wow.
And that's only if you can magically eliminate the time for that, parallelizable portion,
Yeah.
the one you can speed up.
That's amazing. It really highlights how important it is to understand
Yeah.
where the bottleneck is
Absolutely.
in any system, right?
And you know what? It's not just computer programs. It's so many things.
Right. Well, let's dive into that. So we've been talking about these bottlenecks, right? And how they limit how much you can improve something.
Right.
And it makes me think about project management and stuff.
Yeah.
Where you try to speed things up by just throwing more people at it.
Yeah. That's a great point. And this is where Amdahl's law, I think, can be really insightful when we're thinking about project management, right? Because it helps us see that just throwing more resources at the problem isn't always the answer.
Right. So how does that apply to something I don't know, a software development project or something?
Well, just like we talked about with that 100-minute task, right? Projects have parts that can be done in parallel and parts that have to be done sequentially, one after the other.
Right.
Our source gives some good examples of this, right?
Yeah.
So you've got coding, design, testing.
Right.
Those are tasks that you can often, split up among a bunch of people.
You can parallelize them?
Exactly. You can parallelize those.
Okay.
But then you've got things like getting approvals, waiting for feedback,
Right.
dealing with, maybe regulatory stuff.
Right. It's like a process.
Yeah, those are often very sequential. You can't really have 5 people all doing that same thing at the same time. You know what I mean? So
Yeah.
those become your bottlenecks, right? It doesn't matter if you have 10 coders,
Right. If everyone's waiting on that one manager.
Exactly. If everyone's waiting on, one client to get back to you with feedback,
Yeah.
it doesn't matter how many people you have working on the other stuff,
So it's that 100-minute task.
Yeah, it's the same idea.
But it's a 100-day project.
Yeah, exactly.
And that's what they talk about in the source, too.
Yeah. It's a good way to visualize it.
So it's 60 days of the work can be parallelized, but the other 40 you're just can't be sped up.
Right.
So if you double your team size, you'd think, oh, I'll cut the project in half, but it's not quite like that, right?
Right, exactly. You're only cutting the parallelizable portion in half.
Yeah.
Those 40 days, they stay the same. So
Right.
you go from 100 days to 70 days. It's a speed up, sure, but not that magical
Right.
doubling the speed you might think.
This is so interesting. It really just means that more people isn't always the answer.
It's not, yeah.
So it's all about, really thinking about what the bottleneck is
Mm,
and how to optimize that.
exactly.
So, I mean, what would you say, what's the main takeaway for project managers listening to this?
Focus on the bottlenecks.
Okay.
Ask yourself, can we streamline the approval process? You
Right.
know, can we delegate some of the decision making? Are there tasks we can automate?
Oh, that's good.
Those are the areas where you're going to see, the biggest impact
Oh,
on
cool.
your project timeline.
This all makes sense, but in real projects, how does this actually,
Good
play out? Are there examples of where Amdahl's law has really been a factor?
Oh, absolutely. Yeah, I've seen this so many times. I
Man.
remember working with a software development team, and they were really struggling to hit their deadlines.
Mm.
And, they kept adding developers, thinking that was going to solve the problem, but
Right, the classic.
right, but what they didn't realize was that their bottleneck was actually in the testing phase.
Oh, interesting.
Yeah, they had this very complex testing process
Yeah.
that required a lot of, manual effort.
So it was more developers just made more work for the testing people.
Exactly, exactly. It created a backlog of
Wow.
untested code, and it wasn't until they streamlined their testing process, introduced some automation,
Right.
that they actually saw a significant reduction in their development time.
Yeah, that's a perfect example of how just understanding this
Yeah.
can help you make better decisions.
Absolutely.
Right. It's not just work harder, it's work smarter.
Exactly. But, there's another wrinkle to this
Okay.
that often gets overlooked, and that's overhead.
Overhead.
Yeah,
I
overhead.
mean, it sounds like a cost.
It is. It is a cost, and often it's like a hidden cost.
Sure.
Because, in real world projects, things are rarely as neat and tidy as in our, little examples.
Right.
When you have more people working on a project, you inevitably have more communication, more coordination, more meetings.
Right. More back and forth.
Yeah, all that takes time.
Right.
And it adds complexity.
So it's not just the time spent on the task itself, but also managing everyone who's
Exactly.
doing the tasks.
Yeah, and that's what we mean by overhead. It's like the cost of managing all that complexity.
It makes me think about those mega projects
Yeah.
where they have way too many people on it.
Right, right.
And it seems like sometimes adding people just slows it down.
That's a great observation.
Yeah.
And it's often because that communication burden just becomes so huge.
Right. Right.
They use a good analogy in our source material. They talk about communication channels, right?
Okay.
So if you have two people on a team, you've got one channel of communication, but then you add a third person and suddenly you have three.
Oh, right. Right.
Add a fourth, it jumps to 6.
Right.
And it just keeps growing like that.
Exponentially.
Exponentially.
Right. So the more
Really?
people, the more complex the communication,
Yeah.
and the more time you're spending just trying to make sure everyone's on the same page.
Exactly.
And that overhead, it's eating into any gains you got from, being able to do some of the work in parallel.
It totally can, yeah.
So how do we factor that into Amdahl's law?
Good question.
So we were just talking about how overhead can really eat into the gains you expect from parallelizing tasks. Does that mean Amdahl's law needs to be adjusted to account for that?
Yeah, you're right. The simplest version doesn't really capture all that real world messiness.
Right.
But luckily, you can modify it.
Okay.
So you can add in a term that represents that overhead, like how much extra time is
yeah.
needed as you add more people or more parallel tasks.
So it's a more realistic picture that
Yeah.
you're not just thinking about, the time spent on the task, but also
Yeah.
managing all the people doing the tasks.
Yeah, all the communication and stuff.
Right.
Exactly. And when we do that, when we actually use this modified formula,
Yeah.
we often see that the actual speed up is much smaller
Right.
than what we might have initially calculated.
Can we go back to that 100-day project?
Sure.
I'm curious how the numbers change when we
Yeah.
think about overhead.
So remember, we doubled the team size, right? Expecting to cut that parallelizable part of the work in half.
Right.
But let's say for every additional person, there's a 5% overhead.
Okay.
When you factor that in, the project time only goes down to about 88 days.
Wow. So that's a lot more than the 70
Right.
that we talked about before.
It's a big difference.
Yeah.
It really highlights the importance of, realistically estimating that overhead.
Absolutely. So I guess even with these modifications, Amdahl's law, it's not really giving you an exact prediction, right?
Right. It's not a crystal ball.
Right.
Think of it more as a guideline,
Okay.
a way to think critically about resource allocation.
Like what you were saying about the limits of improvement.
Exactly.
So If we're trying to apply this, like, in our own work or on projects,
Yeah, good question.
what would you say, like, what are some of the main takeaways?
Don't assume that more people is always the answer.
Okay.
Just because a task seems parallelizable
Right.
doesn't mean it actually is in practice.
Right. You got to think about the overhead.
Think about the overhead. Yeah.
Yeah. So what else?
Um, Streamline communication, that's huge.
Okay.
So that means clear task assignments, efficient meetings,
Right.
using the right tools.
Make sure everyone knows what they're doing.
Exactly.
And I guess, we can't forget about the bottlenecks.
Of course not. That's key.
Identify those early, figure out how to optimize them.
Yeah, maybe break them down into smaller tasks or,
Delegate.
find ways to automate, get creative.
So it's really, Amdahl's law is like this framework for thinking about decisions.
Yeah, I think that's a great way to put it.
Not just about technology, but
Right. It's broader than that.
anything where you're trying to be more efficient.
Exactly, yeah.
This has been such a fascinating deep dive
It really has.
into Amdahl's law. We've talked about the basics, real-world applications.
All the wrinkles.
Yeah, all the wrinkles.
The overhead.
Yeah. But before we wrap things up,
Okay.
I want to leave our listeners with a question to think about, okay?
All right, I like it.
So now that you know about Amdahl's law,
Mm-hmm.
can you identify a bottleneck in a project you're working on?
Ooh.
Right? Like, take some time, think about how this knowledge can change
Yeah.
how you approach things.
I love that. And, bottlenecks aren't always bad.
Right.
They can be an opportunity to get creative, to innovate.
Right, to find new solutions.
Exactly.
So by understanding this, you're really equipped to make better decisions,
Yeah.
be more efficient.
In work and in life.
Great note to end on.
It is.
Until next time, keep diving deep, keep learning.